Hello students, today we're going to see solving systems of equations using substitution, and on our notes we had discussed about the steps that we need to do this process. I want you to please go ahead and make a change right here on your notes and change this to solve one equation for y or x, and then I'm going to continue with the examples. So these are the three questions that I had assigned for your homework. I'm going to go over the questions, and when you finish going over the video, I want you to make corrections if needed and then start working on the following page. So let's start looking at question number 2. But before we start, I'm going to kind of organize my space right here. So I'm going to make a line right here and another line right here so that I can have a space for every one of these equations. So for question number 2, I'm going to have you guys please copy the equations side by side. So this is the first one, y equals to x plus 1, and the second will be x plus y equals to 5. Notice how step number 1 up here on the instructions tells us to solve for x or y, but the y is already done. Y is equal to x plus 1. So I'm going to substitute x plus 1 instead of the y. So this, because it's equal to y, I can use it and substitute it into my second equation. So the second equation becomes x plus 1. Because this is equal to this right here. Then I'm going to reduce this so that I can find an answer for x. So I put these two together and it gives me 2x plus 1 is equal to 5. Take away the 1, take away the 1. So we end up with 2x is equal to 4. Divided by 2, divided by 2, x is equal to 2. I'm going to use this number to find the solution to the systems of equations. Using the first equation, if x is equal to 2, because that's exactly what we just found, and y is equal to 2x plus 1, then y will be equal to 2 plus 1, which is equal to 3. So finally, the solution to the system of equations, remember, represents the point that simultaneously satisfies both of the equations. So the solution, it's a point on the graph that where the graphs intersect, x comma y. We found that the x value is equal to 2 and the y value is equal to 3. So this is the solution for this system right here. Okay, let's take a look at question number 3 right here. I'm going to zoom in to question number 3. And again, I'm going to have you guys copy the equations side by side. So the first one becomes 3x minus y is equal to 5. And the second equation is negative x plus 2y equals to 0. So from either one of the equations, I need to solve for either x or y. So I'm going to use this equation right here to find how much is the y. So that will be, I'm going to do plus y on both sides. And that makes it 3x is equal to 5 plus y. So then we take away 5 from each side and we get 3x minus 5 is equal to y. Since we know that y is equal to this, I can replace this over here in my equation. So let's show the replacement or the substitution. So I'm going to take this whole thing, take it and put it right in there. So negative x plus 2, that means 2 times y. So that means 2 times 3x minus 5 is equal to 0. Then we start solving for x. So first I'm going to go ahead and distribute the 2 right here and continue. Okay, we will continue in just a second. So we combine these two right here, so that becomes negative x plus 6x equals 5x minus 10 equals to 0. Take away the 10, the minus 10, so we do plus 10 on each side. That gives us 5x equals to 10. Finally, we divide this by 5 on each side, and x is equal to 2. Remember, we're using the substitution method. So far, the solution will have x comma y, which is the point of intersection of the two lines, and the x coordinate is equal to 2. So my solution, we have the 2, so we still need to find the y. So I'm going to go back and replace the 2 into my equation right here so that I can find it. If y is equal to 3x minus 5 and x is equal to 2, then y is equal to 3 times 2 minus 5, which is equal to 6 minus 5. 1. So this right here represents the solution for this particular systems of equations right here. So we have one more example. Let me go back and zoom into question number 4. Now I want you to notice that the x has already been isolated. But just so that we can keep the work nice and organized, I'm going to recopy my equations side by side. 15x minus 2y is equal to 94. And we know that x is equal to negative 3y, so I can go ahead and replace this, substitute it instead of the x. So this is going to go in here. This means 15 times x, so that would mean 15 times negative 3y minus 2y equals 94. Now again, we're going to use this part of the equation to evaluate and find how much is the y. So 15 times negative 3 equals negative 45y, minus 2y equals 94. Negative 45 and negative 2, negative 47y equals to 94. Finally, we divide this by 47, negative 47, and the y is equal to negative 2. Remember, this is part of the solution, so the solution again represents the point of intersection of the two lines, and the y is equal to negative 2. So we still need to find how much is x. We're going to go ahead and use this in the original equation so that we can evaluate and find how much is x. If x is equal to negative 3y and y is equal to negative 2, then x is equal to negative 3 times negative 2, which means that x is equal to 6. So my solution finally is 6 times negative 2. Sorry guys, I didn't realize that you guys couldn't see any of my work. Okay, Let me go back and review the video. If needed, we can go back and change this question. Okay, so for the next thing, I want you to please work on the following page 150 and follow the examples. Make sure you guys are showing your work so that you can get full credit for the questions. Thank you.